folio. So that is the dorsal column of the gray matter. So it is divided into different layers. Several layers. And it has been shown that it ends in lamina 1, lamina 2, and lamina 5. So these are the major layers that receive the afferent fibers. So these are the two fibers that come in, they end here, continue here, and they end here as well. Form their synapses. So this will be the first order neuron. Then the second order neuron continues from there and goes up as second order neuron ending in the thalamus. So it ends, this is already the spinal cord, it ends in the thalamus, and from there it moves to, of course, this is the hind brain, this is the midbrain, so this will be the medulla. To pass through the medulla, go to the thalamus, then send some fibers to the limbic system. As it is going up to the cortex, this is the forebrain or the cortex. It ends in what you call the sensory area of the cortex. Remember I told you the cortex is divided into the sensory area and motor area. So this is where the descending one will start from. So sensory, that will be a synapse from here and here. So this is the interneuron connecting the sensory area. This is called the somatosensory area of the cortex. So you can see this is the second order neuron. Then from here, synapses are also formed again once it hits the brain. This is the spinal cord. So this is the spinal cord as it runs to the cervical area. So this is the, from here it will be the third order neuron. Second order neuron. So this is a pathway the transmission goes from the first order neuron. So first order neuron will involve the dorsal horn, the afferent fibers to the dorsal horn. The second order neuron will move from the spinal cord. It crosses over to the opposite side and ascends through the spinothalamic tract. Yes. We did that before. Through the spinothalamic tract, now the lateral and the ventral. It moves through the spinothalamic tract to the thalamus. That ends the second order neuron. Yeah, the third order neuron relays the signal from the thalamus through the midbrain to the cerebellum. I explained it on this part. I'm talking about the rubbing. So, does it reduce pain?
Yes.
Oh, that's what I want to hear. Reduces pain. Over, this is the afferent fibers enters this way. So when the inhibition comes, it's still going to inhibit it here. So inhibition usually takes place in the dorsal horn. I will draw it later and show you how it works. But again, I mentioned it last time when I talked about postsynaptic inhibition and presynaptic inhibition. I'm still going to draw it again today. Okay, perception. What is perception? Receives the pain, so let's place the dorsal horn here. This is the dorsal horn from where the A fiber came in. The C fiber also came in. They all excite all form synapse with the spinothalamic tract. Okay, so here, this is the cerebral cortex. The divided into two, the sensory and the motor. So once the information is registered by the ascending tract, then it's passed on to this, and then the descending tract continues. Now, this is an area in the midbrain. This area is called the periaqueductal gray. Aqueductal gray. PAG. PAG is made up of cells that contain opioid receptors. What are opioids? Opioids are organic compounds that are capable of what? Reducing pain. So the periaqueductal gray, the cells of the periaqueductal gray express opioid receptors. And because of that, they produce what we call enkephalins, dynophins, and endorphins. These are naturally occurring opioids, dynophins, enkephalins, and endorphins. These are produced in response to the excitation coming. Remember that as this was coming up, let's make it right. As this was coming up, entering, this is the thalamus, this is the medulla, thalamus. As it goes to the, I hope you know it sends a branch here. We mentioned that before. True?
Yeah.
So it sends a, so even before it gets into the cerebral cortex, this one has received excitation. In addition to this, this is already activated. So it's ready to perform its business. So it keeps secreting these chemicals which are naturally occurring opiates. So this one is enkephalin or dynophins or endorphins produced by periaqueductal gray. Then this one, when it produces it, these chemicals will flow to the medulla. This is called, this section of the medulla is called rostral ventrolateral medulla. Rostral ventrolateral medulla. RVM. And it's made up of two groups. So this rostral is going to be divided into two. The more dorsal portion is called the Raphe magnus nucleus. This Raphe magnus nucleus, when it is this two, this enkephalin, will stimulate this to produce what? To produce serotonin. And it will stimulate this. This one is called, the lower one is called the nucleus paragigantocellularis. So, paragigantocellularis. This one produces what? Norepinephrine. So the rostral, okay, let's just say that this is divided into two. The Raphe magnus nucleus and the nucleus paragigantocellularis. So these two is referred to, this is commonly referred to as the rostral magnus. So this one produces what? This enkephalin is produced by what? PAG, periaqueductal gray. Then this flows down to stimulate the medulla, the rostral ventral medulla, divided into two. The Raphe magnus nucleus, it stimulates this to produce serotonin and stimulates this to produce what? Norepinephrine. This one does not flow to the, it is this tube. This is just to stimulate this. So norepinephrine and serotonin will flow through the axon. They will flow through the descending pathway. And can you see that this is a synapse? So this is what pre. This is what? Presynaptic, and this is what? So this is the dorsal horn. So here we have an inhibitory interneuron sitting here. This inhibitory interneuron sends axons to this and also sends axons to this. Can you see that? Can you see that? So this descending fiber carrying, this is by axonal flow. These chemicals will flow through the axons. So serotonin and norepinephrine coming through this will now form synapse with this. Are you seeing that? So this tube will excite this. When they excite this inhibitory fiber, this inhibitory fiber can inhibit this, or it can also inhibit this. Are you seeing that? So if it operates, so this one will give rise to what we call presynaptic inhibition, and this one will give rise to what? Postsynaptic inhibition. So in the analgesic system, in the endogenous analgesic system, inhibition takes place in the dorsal horn of the spinal cord by serotonin and norepinephrine, operating at postsynaptic inhibition or presynaptic inhibition. In presynaptic inhibition, what happens? It prevents this from producing their neurotransmitter. In postsynaptic inhibition, it prevents this from being excited. So we can stop here for today. Unfortunately, the lecture is not recorded. So, but I think it was